Today we're working on solving rational equations. Before we begin, we're going to talk about what do these words mean. Well, we've talked about solving and we've talked about an equation, but we haven't spent a whole lot of time talking about the word rational. Okay, anytime you see the word rational, what they're talking about is a fraction. So what we're talking about today is how do you solve an equation that has fractions in it, okay? So the definition of a rational equation, remember equation is an expression that has equal marks in it. So when you have to solve it, your goal is to get x by itself or whatever variable it is by itself, okay? So when you're solving a rational equation, you're solving an equation that has fractions in it, and it could just have one fraction, okay? And it's going to have variables in it. And your goal is to solve it. So how do you solve a rational equation? Well, the goal actually, which you guys will be pretty happy about, is to get rid of the fractions that are in it. Okay, so to solve a rational equation, your goal to begin with is to get rid of the fractions. So to get rid of the fraction, or the fractions, because there could be more than one, what you're going to do is actually multiply the whole equation. So both sides, everything that's in that equation. So multiply the whole equation by what's called your LCD. Now, it's been a while since you've seen this acronym, okay? But LCD stands for least common denominator. And what this is when you look, remember a denominator is the number that's on the bottom of the fraction. If you look at the numbers that are on the bottom of your fractions that are in your equation, you're trying to find the smallest number that all of those denominators will go into, okay? In other words, divide evenly into, okay? So it's the smallest number that's on the bottom of your fractions that all of them will evenly divide into, okay? So once you do that, once you find your least common denominator and you multiply the whole equation by that, you'll find that it actually makes the equation just like a normal equation that you're used to solving, all right? So to kind of help you understand that, we're going to go straight to examples. So let's say that we have the equation y over 5 plus y over 2 equals 7. And we have to solve that equation for y. All right. Well, notice you've got fractions, you've got variables in there. Okay. And in your fractions, you've got a 5 and a 2. And really, you could think of this like a fraction. Remember, every number is technically understood over a 1. So you could think of that like a fraction, but in this case, we don't really have to. Okay. And so the first thing you want to do is find what number will both of these go into, and you want to try to make it the smallest number that you can, just because it'll make the math a little bit easier when you actually do it. But what number will 5 and 2 both go into evenly? That's what's called your LCD. Okay, and so if you kind of sit there and do a little calculation, you'll find that 5 and 2 both evenly go into 10. So the smallest number that both of these will evenly divide into is 10. All right. So what you have to do with that number is you have to multiply that whole equation by that number. All right. So I'm going to take that entire equation and I'm going to multiply it by 10. So what you're really doing is it's almost like you're going to take that 10 times every single piece in that equation. Okay, and you multiply it times the tops of those. All right, so when you do that, you would have 10 times y, which is 10y, and then that's still over 5. Okay, you'll see why it works in a minute. Plus, then we take the 10 times this y, so it'd be 10y over the 2, and then equals, I'm just copying my equation down, equals, and then 10 times 7 is 70. Okay, now why does this work to get rid of the fractions? Well, notice what you've done is you found a number that both of these will go into. So what's going to happen is it's actually going to make these denominators go away. Because notice 10 over 5 will reduce. 10 divided by 5 is 2, so you get 2y for that one. And then for this one, so that'd be plus, 10 over 2 is 5, so that'd be 5y equals, and then that 70 just comes down. Notice it has made this problem a whole lot easier than when we started. So from there, you just solve it like a normal equation. Notice these are both on the same side of the equation. So you just combine like terms. So 2y plus 5y is 7y. And then bring down my equal 70. And then to solve from there, to get y by itself, you divide by 7. You have to do that on both sides. So it'd be 7 over 7 is 1, so they go away. And then I'd have y equals 70 divided by 7 is 10. So y is equal to 10. Okay? So hopefully that kind of reminds you of how to find the least common denominator. All right, but we're going to do another one. So let me go over here and put another one. So let's say this time we have 2 over y plus 1 over 2 equals 5 over 2y. Okay. So with this one, you'll notice that it is a little different than the other one because now we actually have variables on the bottom of the fractions. When there are variables on the bottom, that's actually going to bring us to talk about what are called restrictions in your equations. Okay. And so a restriction in your equation is something that because you have variables on the bottom, if you remember something we talked about, or you would have talked about in math classes before this, would be a number that you cannot have on the bottom of a fraction. And if you remember, you're not allowed to have 0 on the bottom of a fraction, or it would actually make the number undefined. And so a restriction that we're going to have here is any number that y could equal that would make 0 on the bottom. And so think about, on this fraction, if we solved for y, kind of like what we did in this one, and we ended up getting y equal to some number, what number could we not have here in like that we could plug in for y? Well, think about it. In this problem, if we had a 0, if y was equal to 0, then it'd be 2 over 0, and that wouldn't work, right? That would be undefined. So a restriction in this problem is y can actually not equal 0. And then look over here. What number could y not be? Because if it was, then we'd get a 0. And notice it's 0 here too, because if we take and plug in a 0 for y, well, 2 times 0 would be 0, and we'd end up with a 0 on the bottom of the fraction here. So a restriction that we have here, a number that y could not be, is 0. Okay, so anything that would give you a 0 on the bottom of the fraction, that's going to be a restriction. And so in a minute, we're going to put at the bottom of it, when we actually solve for y, we're going to make sure, number one, that it's not 0, because if it was, then we couldn't say that that's an answer that works. Okay, that would be an extraneous solution. Okay. But in a minute, we're going to just add that to our answer, is that y cannot equal 0. Okay, so let's solve it. First thing, just like we did in the other problem, is we had to find the least common denominator. What is the smallest number that all of these denominators will go into? And so it will be a little different in that sense too, because we have variables. And so when you have variables, You just have to look at what variables they have, and you have to include that in your LCD, or your least common denominator. So I just write it to the side here. Notice number-wise, you've got a 2 and a 2. So since they're the same, what's the smallest number that 2 will go into? Well, that would be 2. So that has to be part of your common denominator. And then if they have a variable, you just write down the variables. And if they had an exponent, you choose actually the one that has the higher exponent. Okay. And so notice they have a y. So you want to include a y in your common denominator. Okay. So after that, that's everything that you see on the bottom. Okay. So you just kind of list out in a way what you see on the bottom in terms of variables. And then, just like in the other problem, we take the entire equation and we multiply it. So I'll put it back here because I don't have room in front. You multiply it times that least common denominator. Okay. So again, it's like distributing it to everything in your equation. All right. So when we do this one, it'd be 2y times 2. So we get 2y times 2 is 4y. And then that's over y, plus, and then 1 times 2y is 2y, and then that's over 2, I'm just bringing my 2 down, equals, and then we take 5 times 2y, so that would be 5 times 2 is 10, and then I bring the y over, so 5 times 2y is 10y, over, and then I bring my 2y down. All right. So now, again, the whole reason you do that is so that your fractions will go away. And so if they don't go away, that means your least common denominator might have been wrong. Okay, so you just have to adjust that and then redo it. All right. So notice when I have 4y over y, because I have the same number on the top and the bottom, or the same variable on the top and the bottom, y over y is 1. And so that leaves me with 4 here because they'll go away. Plus, and then notice I have a 2 over 2. 2 over 2 is 1. So that'll be like 1y. So I'm going to bring down my y. And then I have 10 over 2, which is 5. And then y over y, well, that's a number over the same number. So that's 1. And so it's going to go away. And so this is like the easiest equation you could be left with. You just have to solve for y. So since we're adding a 4, we subtract 4 to both sides. Get it to the other side, because remember you do the opposite, so those go away. And we're left with y equals 1. And so, looking at my answer compared to what y could not be, so that we don't end up with a 0 on the bottom, I'm okay. I don't have a 0 for the y, or y is not equal to 0. So this answer is perfectly fine to have. And then in the homework, a lot of times they will ask you for what the restriction is. So you can just put it at the bottom here. So the restriction would be y could not equal 0. And so since we didn't get y equal to 0 when we actually solved, we're in good shape. All right? All right, so let's do at least a couple more to make sure that you guys kind of know how it works. And then I'll let you guys work. All right, so I'm going to flip over. We're going to do a few or a couple more. All right, so this would be example number 3. So let's say that we have 1 over 4x minus 3 over 4 equals 7 over x. Okay, notice we have a denominator that has a variable in it. Okay, when we have that, you want to go ahead and think about what number could this not be equal to, so that we don't end up with a 0 on the bottom. The goal is not to end up with a 0 on the bottom of your fraction. All right, so what number could x not be here? And notice, think about if x was equal to, for instance, 0, think about what you would get on the bottom of the fraction here. You'd get a 0. So x, the restriction here is x cannot equal 0. And then look at anywhere else you see the x on the bottom, that's over here. What number would give you a 0 on the bottom here. Well, if I plug a 0 in for x here, that's going to give me a 0 on the bottom. So it's the same story. Okay, so x cannot be 0. So that's our restriction. That's what we're looking out for. Okay, so just like before, we got to solve. So we've got to find what number will all of these go into evenly. Okay, so I'm going to write that to the side. What's the smallest number each of these will go into? So look at your numbers first, just the regular numbers. Well, you got a 4 and a 4, and then technically that's like a 1. So what's the smallest number that 4 will go into? Well, that'd be 4. Okay. And then, like I said, with the variables, if you have a variable, you write it down. And if it has an exponent, then you write the one that has the biggest exponent. And notice there's just an x. So we're just going to write that down as part of our least common denominator. Okay. Then there's nothing else on the bottom that we need to include. So you take the entire equation and you multiply it times that. Okay. So again, it's like you're distributing it to every part, both sides of your equation. Okay. And so when I do that, it'd be 1 times 4x, which is 4x. And then I'm going to bring it the bottom 4x down. Okay. Remember, you just take it times the top of the fractions. Okay. Minus 3 times 4x ends up being 12x. And then I bring that 4 down, equals 7 times 4x is 28x, and then the x is on the bottom of that one. Okay, so just like I said before, the whole reason you do this, you multiply it by the least common denominator, is when you simplify these fractions, it should actually make the fraction part go away. So notice 4x over 4x, that's a number over the exact same number. So remember, that actually becomes 1. So this is just 1. You can't just leave it blank. It's actually a number, so make sure you put a 1 there. And then 12x over 4, well, 12 over 4 is 3. So that'd be minus 3, and then the x just comes down. And then notice here you got an x over x. So the x's are going to go away because that's 1. So it'd be like 1 times 28. So equals, bring my 28 down. All right. And then from there, I just have to solve for x. So notice we've got 1 minus 3x. A lot of people are going to make a mistake and want to add the 1 because they see this negative. But notice you actually, this is technically a positive 1. So you want to subtract the 1 first. Okay, so to get that 1 over there with the 28. So 1 minus 1 will go away. And then the negative 3x will come down. And then that equals 28 minus 1 is 27. And then from there, this is negative 3 times x. So you have to divide by negative 3 on both sides. So negative 3 over negative 3 will be 1. And then I'll have x equals 27 over negative 3, negative 9. Okay. Notice we just have to look out. Did we end up with x equal to 0? Well, no, we ended up with it being negative 9. Okay. Now, and then again, you have to include the restriction. Now, something we have not talked about yet is just like what you did when you were solving radical equations, it is always a good idea to check your answer, to go back and plug in this number that you got and double check to make sure that it actually works in your equation. Okay, you're going to find out when we do some of the harder problems tomorrow that that's going to be super important to check. Okay, and all you have to do is just, if you're not a fan of fractions, you can just type it in your calculator, 1 over 4 times negative 9, and figure out what that is, minus 3/4, figure out what that side is equal to, and see if it equals 7 over negative 9. You just go in and plug it in, okay? And if you do that, that will work, okay? And so that is our answer. All right. So let's do one more, and then I'll let you work. And then if you have questions, remember you can always email me or join the Zoom session. All right. So let's do this one. All right. So with this one, we again have fractions and we have variables, but this time I didn't put any variables on the bottom, so we're good there. Okay. But you still have fractions. So find the LCD. And so we don't have to talk about restrictions here because there's not a variable on the bottom of your fraction. Okay. So what is the smallest number that both of these numbers that are on the bottom of the fraction will go into? So think about 4 and 8. What's the smallest number that both of these will go into? And some people will have trouble with this one, but think about it. Don't both of these numbers go into 8? So then the least common denominator would be 8. Okay, and then notice there's nothing else on the bottom of the fraction, so that is the least common denominator. So you just take the whole equation and you multiply it by that number. So we distribute that number, we distribute that number to all of the parts of the equation. So 1 times 8 is 8, and then I just bring down the 4 that's on the bottom, minus, so this is technically over 1, that's why I didn't really have to consider it. And so that'd be minus, and then x times 8 is 8x equals, and then 8 times x is 8x, and then that's over 8. Okay, so let's simplify. 8 over 4 is 2, and then I bring down my minus 8x because there's nothing on the bottom, or there's just a 1, so it just come down. And then 8 over 8 will be 1, so this is like 1x. We just write it as x, and then we solve. So just like the last problem, you want to get this 2 over there. And notice it's a positive 2, so you subtract 2 to both sides. And notice those are not common terms. So subtracting 2 actually may not be what you want to do, okay? Because these are not like terms. You want to get your like terms together. So instead of doing that, you would actually add the 8x. Okay, and what you do to one side, and we're adding it because we were subtracting it here. What you do to one side, you got to do to the other. So I add it to both sides, and then that 2 will come down, and then these will go away. So I have 2 on this side equals, those will combine, and I get 9x, x plus 8x. And then I've got to solve for x. Well, it's being multiplied by 9. So I have to do the opposite, which would be divide by 9. Those will go away. So I'm going to move my x over here. X would equal 2 over 9. Okay. And then just like I said before, it's always a good idea to check your answer. So you would just take that and plug it back in for x and make sure that this side, when you plug it in, equals that side. Okay. And whenever I did that, it does work out. And so there we go. All right. So we'll do some of the more challenging problems tomorrow, but for now, just practice these problems and have a good day.